All right, everyone. So we're going to learn in this video about dimensional analysis, which is one of the most important skills that you're going to need for second semester. We're going to learn it on this first day, and you are going to literally need it for the rest of the semester. So in science and math, we often convert a number or a quantity, a value, from one unit to a different unit. So we say, 1,000 meters is 1 kilometer, right? We want to convert from meters to kilometers, just different units of measurement. And so dimensional analysis is a method to convert one type of unit to another. It's the process by which we do that. And this way we convert to a different unit of measurement, but the value stays the same. So when we do that conversion, we use an equality, which can be written as a conversion factor, which is the equality, but written in as a fraction form. So you can see here, this equality says 1 ream of paper is equal to 500 sheets of paper. That's why it's called an equality. We're saying this one value is equal to this other value. And so we can see that we have the number 1 and the number 500. We have our unit. So in this case, it's a ream, or we're talking about individual sheets, okay? And then we see that the identity, what are we talking about? We're talking about paper. The identity stays the same, but the number and the unit represented to use the same amount of paper is different. In both cases, you have 500 individual sheets of paper, but in one, you're saying that is all called 1 ream versus 500 sheets. And so as a conversion factor, what this means is we're writing it in its fraction form. So we can see that we have 1 ream of paper over 500 sheets of paper, or 500 sheets of paper over 1 ream of paper. So it can be written in either way. It's just kind of flip-flopped in each version, but it's the same value. So when we use dimensional analysis, so if we look at this, it says if I want to know how many sheets of paper are in 5 reams of paper. So this is what I'm given. This is what I have. We can use dimensional analysis to convert using the equality and a conversion factor from above. So we set it up like this. We put our given right here. Okay, so we have our given, and we see that we used a conversion factor here. Now, the reason that matches with this conversion on the right. Now, why did we use that one? Why didn't we use the other one? Well, what we know is that I'm trying to convert from reams into individual sheets. And so we want to be able to get rid of the word reams from our given number, 5. And so in order to cancel something out, in order to get rid of something, it needs to be on the top and on the bottom. So because reams of paper is here, I needed to choose a conversion factor that would have ream at the bottom of the fraction in order for these to cancel out. And so that meant I needed to use the conversion factor on the right. The conversion factor on the left would have had ream at the top, and those units would not have canceled out, so that when I say 5 times 500 divided by 1, I get 2,500 sheets of paper. So I wanted the word reams to go away, and I wanted the word sheets at the end. And so when we think about, okay, what is dimensional analysis? It is a method to convert units. Okay, all we're doing is converting units. And what do we need in order to do that? We need an equality written as a conversion factor. We need to know, okay, how are these units connected? What are these values equal to? And so if we're going to set up a dimensional analysis problem, let's just do a couple of examples here. Okay, we see that Jean weighs 120 pounds. What is her weight in kilograms? And we see that we have an equality here. 1 kilogram is equal to 2.2 pounds. Now, we know that that equality can be written as a conversion factor, 1 kilogram over 2.2 pounds, or it can be written as 2.2 pounds over 1 kilogram. We just have to decide which one we want to do. So when we set up our conversion factor, this is, I call this a T-chart here, and we take what is given to us, in this case our 120 pounds, and we put it in the top left. So we have 120 pounds, and we know we need to get rid of the word pounds. In order to do that, it's going to have to appear at the bottom. So these values, or these units, must match. Now, when we look at our different options for our conversion factor, the only one that has pounds at the bottom is this first unit here. So I will write my conversion factor that way. I will put 1 kilogram at the top and my 2.2 pounds at the bottom. And so we see that when we do this, we're always going to multiply by what's at the top and divide by what's at the bottom. And so this gives us 120 pounds times kilograms over 2.2 pounds, right? If I'm just multiplying across the top. And then we see that pounds are going to cancel out, and 120 divided by 2.2 is 54 kilograms. 54 kilograms. And we don't necessarily have to separate it out with the 120 pounds per kilograms. I just want you to see why these units end up canceling out, because they're on the top and the bottom of our fraction. So they cancel out. Let's look at number 2. It says a person's weight is 154 pounds. Convert this to kilograms. And again, we have the same equality. We have 1 kilogram over 2.2 pounds, or we have 2.2 pounds over 1 kilogram. It just depends on which one we'll need to use. So we set up our T-chart, and we take what's given to us, our 154 pounds, and we put it in our chart. Now, because I have pounds again here, I will need to have pounds at the bottom of my fraction. So that means I will be using that first fraction there. So again, 1 kilogram over 2.2 pounds. And so we multiply by what's on the top and divide by what's on the bottom. So 154 times 1 divided by 2.2 gives us 68 kilograms. Excellent. And that is our answer. Now, when we look at number 3, we see it says convert 9.85 liters to gallons, and we have a different equality this time. Here we have 1 gallon over 3.78 liters, or that could be expressed and written as 3.78 liters over 1 gallon. So we set up our T-chart. We put our line, we take what's given to us, 9.85 liters, and we have to choose our fraction. We see that if I have liters here, that means I'm going to also need liters at the bottom. The fraction that has liters at the bottom is our first one, so that is what I will put in my chart. I will put 1 gallon at the top and 3.78 liters at the bottom. Liters will cancel out, so that my only unit left is gallon, which is what I wanted. And 9.85 times 1 and divided by 3.78 is going to give us 2.61 gallons. And since it's more than one, we'll add our S there. And so this is how you do basic dimensional analysis and unit conversions. And you can do multiple steps in one, which we'll see that later. So this is dimensional analysis, everyone.